Good morning, everyone. So today we're going to be taking a look at the last section in this chapter 9, which is 9.5, the fundamental theorem of algebra. So as you're watching this video, feel free to pause at any time to take down some notes or to rewatch anything that you weren't able to catch on the first view. All right, so we're going to go ahead and start with talking about what the fundamental theorem of algebra actually is. So it's pretty simple. The fundamental theorem of algebra basically just says that if a polynomial has an exponent or the degree of the polynomial, which is basically the greatest exponent of the polynomial, if it's greater than 1, it means that the equation, when we set it equal to 0, is going to have at least one answer for x. And that answer could be a whole number. It could include something with a radical. It could be like a fraction, like what we've seen when we use quadratic formula. And it can even have imaginary numbers. All right, so we're going to go ahead and start with example 1. Now notice that the greatest exponent in example 1 is 3. We have not solved anything like this yet, and so this is going to be pretty new. And there are basically 3 steps that we're going to take. Step 2 is kind of the biggest step, meaning it's kind of the most work, but it's already these are some things that we've already done in the past, so hopefully it'll just kind of be a collection of the skills that we've used before, and so hopefully that'll make it a bit easier to understand the process. So the first thing that we want to do is when we're solving for a polynomial, we want to make sure that it's set equal to 0. So this example is already set equal to 0. And what we're going to do first is we're actually going to look for all the possible answers, possible whole number answers for x. Now, this is just a minor check. This doesn't mean that all the numbers we come up with right now are going to be like the bank of answers that we could get. This is just checking for rational, the ones that are like whole numbers or fractions or things that are just not imaginary or radicals. All right, so let's just keep that in mind. So we're going to go ahead and do step number 1. And what we're going to do is we're going to find the possible rational roots. So we're looking for what are the possible x values. We're kind of jumping right into like what are the x's that could just be the answer. So there's a trick to this. There's I guess you can call it a formula. What we're going to do is we're going to write down all the factors of the constant term. The constant term is the regular number in the problem. So in this problem, it's positive 12. It has no x on it, so it's the constant. It's basically a value that never changes. That's why it's constant, because all the other 3 terms can change because we don't know what the x attached to it equals. So the constant term in this case is the one that never changes, which is positive 12. And then we're going to divide that by all the factors of the leading coefficient. So the leading coefficient is the number, the coefficient in front, which in this case is 1, which is the coefficient of x cubed. So let's go ahead and write that out. So factors of the constant term, all the numbers that divide into 12. So that would be 1, 2, 3, 4, 6, and 12. And we need to make sure that we consider both the positive and negatives of those factors. So we're going to write plus or minus 1, because 1 divides into 12, plus or minus 2, 2 also divides into 12, plus or minus 3, plus or minus 4, plus or minus 6, and plus or minus 12. So these are all numbers that divide into 12. And then we're going to do the same thing in the denominator. We're going to look for all the factors of the leading coefficient. So what are the numbers that divide into 1? Well, it's only plus or minus 1. So it's nice when that happens. So now we're going to simplify this a little bit. We're actually going to start dividing these. So what's 1 divided by 1? Well, that's plus or minus 1. What's 2 divided by 1? Well, that's plus or minus 2. And so we could do that for every single one of these numbers, and basically we end up getting exactly what we have in the numerator. So that's how it worked out in this one. Sometimes you'll actually be able to divide, but in this case, it just worked out that way. All right, so now we're ready for step number 2. Step number 2 is where we have most of the work, in my opinion. And we need to use synthetic division. What we're going to do is we're actually going to start testing which one of these possible roots, which one of these possible x values is actually an answer. So could positive 1 be one of the x values? Could negative 1 be one of the x values, one of the answers for x? Could it be positive 2, negative 2? We know that there's only going to be 3 because that's the greatest exponent in the problem, but we don't know which 3. So what we need to do is we need to start testing them, all right? So the first thing that I'm going to do is I'm going to test positive 1. Now, if positive 1 is one of my x answers, that means it must have come from something like x minus 1 equals 0. This would have been the parentheses that an answer like positive x equals positive 1 would have to come from, right? Because if I solve this, I would do plus 1 on both sides, and I would get an answer of x equals 1. So an answer of x equals positive 1 comes from the parentheses x minus 1. So just keep that in mind, because when we do synthetic division, you have to remember that we use the opposite number in the box. So let me show you what I mean. So we're going to set up the little box in the corner. If you remember from synthetic division, we're going to use all of the coefficients of the polynomial. Okay, so all the numbers in front of our x's and then our constant. So that's a 1, a negative 2, a negative 11, and a positive 12. All right, so I'm going to test to see if 1 is an answer. So that means that in my box, I have to write a negative 1. That's how it works. That's how synthetic works. So I'm going to bring down my first term. That only happens the very first time you use synthetic. So we're going to bring down the 1, and then we're going to start multiplying. 1 times negative 1 is negative 1. Then we add these two values, so we get negative 3. Negative 3 times negative 1 is a positive 3. We add those together, we get negative 8. Negative 8 times negative 1 is positive 8. We add those together, and we get 20. So here's what happens. We end up with a remainder. When we have an x value that works out perfectly, there should be no remainder. So that means that x equals 1, this positive 1, is not a possible answer. So what I'm going to do is I'm going to go back, and I'm going to try another one. So I'm going to erase this negative 1. I'm going to erase all this work, because I need to redo my synthetic division with another possible root. All right, so this one didn't work. And that'll happen sometimes. You might have to do a few before you find one that works. Okay, that's why I said step 2 is the one where there's a lot of work. So positive 1 didn't work, but maybe negative 1 will work. So we're going to test negative 1. So that means that in my box, I'm going to have a positive 1. So again, I'm going to bring down this positive 1. It happens to be a coincidence that we're using positive 1s right next to each other. There's no relation. That's just a coincidence. So I'll bring down that 1. 1 times 1 in the box is 1. Negative 2 plus 1 is a negative 1. Negative 1 times 1 is a negative 1. I add those together, I get a negative 12. Negative 12 times 1 is a negative 12. I add those together, and I get a remainder of 0. Perfect. That's exactly what I want. So what that means is that this root of a negative 1, which comes from a parentheses of x plus 1, is actually one of my roots. One of my factors. All right. So I tested negative 1, which came from the parentheses x plus 1. So here's what we're going to do. We are going to move on to step 3 because we found one that works. Okay, so step 3, we're going to factor and solve. Okay, so I'm going to put everything in parentheses form. I'm going to factor it all. So I have x plus 1. This one comes from this positive 1 right here. And I actually have the rest of my factors. This is my other polynomial. You just have to make sure you put all the x's back. So remember when we did synthetic division, when we were ready to put all the x's back into our answer, we had to go back to the original problem and look at the greatest exponent and then start with the next one down. So that means that I'm going to have an x squared here, then a regular x, and then no x on my negative 12. So my factor, what I'm left with is 1x squared, which is just x squared, minus x minus 12. And remember that that's all still set equal to 0. This right here, just to be really clear, is essentially just the original problem, only it's written in factored form. That's all we're doing. We're just rewriting it with its factors so that we can find the roots, so all the values for x. So we do that by factoring, by using quadratic formula, there's all these different methods. So let's go ahead and check, can we still keep factoring? Well, we have a trinomial, and it definitely looks like I can factor. So I'm going to bring down this x plus 1. There's nothing left to do with it. And then I'm going to factor. Now this is a trinomial where a equals 1, so all I need to do, I'm going to put my x's in place, all I need to do is find two numbers that multiply to, really I just have to check for something that multiplies to 12, right? And adds up to a negative 1. So I have 1 and 12, 2 and 6, 3 and 4. Now if I want to add up to a negative 1, which is my b term, looks like 3 and 4. Oops, sorry, erased that by accident. Looks like 3 and 4 are going to be the numbers that work. So I'm going to put a 3 and a 4. Now let's make sure we get our signs right. I need these to multiply to a negative 12 and add up to a negative 1. So I'm going to do a negative 4 and a positive 3. And here's why. 3 times negative 4 equals negative 12. And 3 plus negative 4, or really 3 minus 4, also equals negative 1. So I found the two numbers that multiply to C but add up to B. Okay, now once you're at this step, you are super close to being done. The only thing now we need to do is figure out what x actually equals. So we have 3 parentheses equal to 0. So this is something that eventually we can just do mentally. But right now I'm going to show you how I'm going to set up 3 equations that will give us our answers. So the first equation is going to come from the first parentheses. X plus 1 equals 0. And I'll solve that in just a bit. The second equation comes from the second parentheses. X plus 3 equals 0. And then my third equation comes from my third parentheses. X minus 4 equals 0. So I'm just going to solve these. And these are going to work out really nicely. So here I just have to do minus 1 on both sides. And I get an answer of negative 1, which I already knew. This answer right here is what I checked in the beginning. I was checking if x equals negative 1 is an answer. That's why when I did synthetic division, I plugged in x plus, or I plugged in a positive 1, because I knew that it would come from this kind of parentheses where it would be x plus 1. So I already knew that x equals negative 1 was going to be an answer. So I'm going to circle that in, or box that in. Then for the next one, I'm going to do minus 3 on both sides. So I get x equals negative 3. It's my second answer. And for the third one, I'm going to do plus 4 on both sides. And I get x equals 4 for my third answer. Those 3 are my answers. And it makes sense that I have 3 answers because the greatest exponent in my problem is a 3. All right, so I would encourage you to rewatch this if you need to. There is going to be a practice problem that you're going to try, and it'll be very similar to this one. But again, I don't expect you to master this after having watched the video once. So please watch the video again if you need to. Pause wherever is necessary. And after trying the example, if you have some questions, feel free to log back in and I will help you. All right, so that's it for today.